entitled Software Architectural Decisions, the Azure Journey, and it will be given by Aitor Echevarría and Rubén López. It's a great pleasure for me to introduce them. Both of them are studying computer science, one in La Coruña and the other one here in Oviedo. I was a teacher of him, and for me it's a great pleasure to introduce them, and the floor is yours.
All right, thank you very much. Welcome everybody. First of all, thank you for dedicating your valuable time to come to attend this conference, and thank you, Emilio, for trusting us, thinking that we could have some interesting things to share with you today. So thank you very much. Let's start with the introductions. My name is Aitor Echevarría. As Emilio said, I studied computer engineering in Galicia, in A Coruña, because I'm from Galicia, from Ribadeo, not very far away from here. And my first job experience was working in the software architecture department in the university. I spent there a couple of years, and then I started working in a company involved in the public administration projects. And then in 2011, I joined CSC, which is the former company now known as DXC, my actual company. And since then, I worked in international projects, different sectors like banking or healthcare. And finally, around 2015, I believe, I joined the DXC division insurance software company. And since then, I've been involved mainly in the building software for insurance companies, and I belong to architecture and engineering team. That is pretty much the part of the presentation that I really did have time to prepare. From this point on, it's going to be a little bit of improvising. This is a warning. I didn't have much time to prepare this speech. Now I have the pleasure to introduce also Rubén.
Thank you, Aitor. Hello, good morning, everybody. So my name is Rubén. I'm a software architect at DXC Technology. We are mates on the same company since a long time back. I joined DXC nearly 20 years ago, and I've been taking different roles, starting as a primary analyst on different sectors, for local market, for market in Iberia, in the country, and multiple clients and different kind of services, and taking the different responsibilities, keeping in charge of maintaining teams as well. But my main focus has been around software engineering and software architecture. And since more or less 5 years ago, I joined this very interesting, as we will see, product or project development, and that's where I've been developing my recent role as a software architect. So that's a pleasure to stay here and to share what we have learned and our experiences around designing a system. So hopefully we will not boring you too much. Okay, so well, maybe one of the first questions is why 2 speakers? But well, everything fails. We know all the time as Werner Vogel, the CTO of AWS, said that everything fails, and the best way to avoid the failure is to be prepared for that, and to assume the failure as a natural occurrence. So, well, this is aligned with the failover pattern, where a system remains operational even if a component fails. There will be a backup to take the workloads for that. But, well, not sure if in this case it may work. Taking the analogy for this presentation, we will say that this presentation is stateful and not stateless. It means that Aitor will present some contents, and I will take care of other contents. So if any of us fails, we will not take care or fail over to the other one. So not sure if that's, that pattern will fit better or will fit properly here. Of course, in the real world, there are some decisions, some technical decisions that make it possible. Okay. Okay. So starting with the agenda, Aitor will present the agenda, and just to let you know, we will be switching back and forth because we have distribute the contents between us. Okay, thank you.
Yeah, sorry for this inconvenience, all the back and forths, but yeah, we didn't really have much time to prepare this presentation, and yeah, splitting the content was the best approach. So you can see the agenda in this slide. We have like 3 different parts. First one is kind of an introduction. We will cover some general ideas and fundamentals about software architecture. The second part is the major block, right? Is where we will be presenting our first-hand experience in our current company for the last years. And then to wrap up the speech, we will try to share with you some ideas about what is the present and the future for software architecture. Yeah, and again, sorry and apologies, we are not very good speakers. We could consider ourselves like rookies in this matter, right? And also my voice is not the best of my qualities or my skills. So I hope you can hear me properly. Okay. I will try to do my best. First slide, expectations against reality. All right, folks, you've been in this field of architecture engineering for some years. You are students. But it's quite different when we discuss about software architecture with people who are not very familiar with these topics, right? So, for example, we could imagine what my parents or my girlfriend think when I talk to them and I try to explain what is software engineering or what is software architecture or what do I do for a living, right? So I think that this is more or less what they think I do, right? It's like the good-looking guy, all dressed up, ready to do my next conference, traveling around the world, taking important decisions every day. Okay, that is not really very, very aligned with what I do, right? When I talk to my friends, for example, and I explain I do software engineering, well, they have other inputs because they see myself all the time spending long hours working with my laptop, so they might be thinking something like this. And this is pretty aligned. I mean, this is a guy quite stressed with multitasking, with a lot of things going on, drinking a lot of coffee, spending endless hours in front of your laptop. Of course, the whiteboard is a must for drawing diagrams and taking really important decisions. And yeah, this is pretty aligned. And now, the reality. And I'm gonna let Rubén explain what is the reality of this picture?
Well, the reality is that we are people taking different hats and assuming multiple roles on our daily basis. It's even reaching to the extreme where we can prepare a paella for 20 people with very few instructions and little experience, and in a parking slot. So that's where where we are at the end of our career. After these 20 years of assuming many different kind of activities, we can do even that. Okay, so let's jump to the first section, where it's related to some concepts or some fundamentals. We will spend a few minutes explaining our overall vision on what's architecture and why it's important, and some types of different architectures that we think are important. So we will be able to correlate that with the use case that we bring today here, which is the Azure journey. Azure is the name of our product, of the product that we design and we build, and we will go into the details after these fundamentals. Okay, so well, all of you for sure will have an idea or more than an idea of what software architecture. Here I'm presenting just the definition from Wikipedia, and basically it refers to all the fundamental structures of a software system, and it refers on how to create these structures, and the main thing is how to take the significant decisions about the organization of the overall software, and that's important. The overall is the difference between software designing an architecture or bringing a technical design. And there are two fundamental laws. Of course, everything is a trade-off, and when you are designing an architecture, you need to assess many different factors that will affect your system once it's built. And in this case, we need to focus in the why more than in the how. So usually this kind of decisions, because everything is about fundamental decisions, will impact on the future changes. These kind of decisions are hard to change once they are implemented, are more costly. So it's important to spend some time designing and taking your right decisions for your system. And in this case, this reference from Martin Fowler is basically saying that, explaining this idea that if we design a system with and take time to analyze all the factors, we will end up building a system that a high-quality system, and on the other hand, if the decisions are not really well analyzed and not spending the right time to come with them, it will finally create a system with low quality. And the difference here is that a low quality system, even at the beginning, it seems it can be really a nice system, but after some time, not too much really, the system will be reluctant, or it will be difficult to add more features or more functionality to that system. On the other hand, high quality system is more wide stand to the time, so will be more easier to maintain, easier to evolve, because the pillars are more robust. So here, these three ideas on the left, or three concepts on the left, is that the software architecture is the foundation for system quality, as we are saying. It facilitates the communication. It tries to provide a common language and a common understanding across all the stakeholders. When you are designing a system, there will be usually different parties or different stakeholders. You need to deal, you need to deal with the business owners and align business goals with technical requirements. There is always a technical constraints depending on your landscape and the decisions you take. So it's important to get alignment between all these parties. And of course, this is the blueprint. The software architecture is the blueprint for developers. So developers will take this blueprint and will get the guidance they require to start building the system. And I will finalize this section with a couple of ideas. I was mentioning that before, the difference between the structural decisions and the technical design. Structural decisions is more about analyzing at high level the overall organization of the system and selecting the right architectural patterns. It can be microservices, monolith architectures. It's important to focus on that, and determining the boundaries of the modules you will use, and identifying and establishing the communication protocols between all the components. The impact is broader in this case because it aims to analyze a system end to end, and as said before, it's usually costly to change once these decisions have been implemented. On the other hand, a technical design is something more granular. The scope is more specific to individual components or individual modules of a system, and thus the changes on these components are usually provides less impact on the overall system, and is more about specific details, implementation details, selecting the data structure, selecting the right algorithms, and so on. It's important to keep in mind this difference, right? And here one idea is that, one statement is that all the systems have an architecture, even although you've not planned for that, but your system will have an architecture. It's what we will call an emergent architecture, something that is unstructured, not following a process, and following more a reactive approach. Even in that case, your system will have one architecture that maybe will derivate in a low quality system, but the system will have an architecture. And so the planned architecture is when you are intentionally designing in an structured way an architecture for your system. So the conclusion here is it's evidence that the system will withstand more the test of time, is more adaptable to any kind of change, and will scale efficiently as your business requirements are evolving. on the emergent architecture. The system will show quite soon technical debt, inefficiencies. It will be difficult to evolve this kind of systems, and you will have more cost of maintenance, and will be more complex to add functionality, because all the systems, there are no systems that remains untouched, and the business requirements are evolving, the technical requirements are doing the same, so we need to think of that as well. And I hand over to Aitor. Thank you.
Thank you, Rubén. All right, I know that these topics are a bit boring, and you might have been discussing already these topics with your teacher. Apologize again. We didn't really feel comfortable jumping straight to the use case without covering very, very quickly these general topics. So I will try to speed up as much as possible. This slide is about who is the software architecture role. The software architecture is a person or artificial intelligence who is responsible for making those significant high-level decisions that Rubén was explaining. They are significant because the definition of significant means that they are hard to change. It's costly to change it in the future. And those decisions has a direct impact on the quality of your system, all the pillars of your system. Of course, the security, the performance, and very, very, especially on the maintainability and the extensibility of your product. So how your product is going to evolve with the time, and how it's going to be able to, as Rubén explained, include more functionality or more features. So this slide is about the different profiles that we could find as software architects. You might be or might not be familiar with the profile shapes. These are two of the most common ones. The profile shapes are things that the recruiters invented or made up some time ago to better describe, the skills and the expertise of the people that they were recruiting. So starting on the left, we have the T-shaped employee. The broader side of the T is, you can imagine, is the whole spectrum of the software engineering. I mean, from left to right, you know a little bit of everything, right? And then you are gaining some depth of a particular domain, which is at the end your expertise. To me, to better explain these shapes, I would put also an additional arrow saying that you should first gain the broader knowledge, and then through the time or evolving with the time, you should be getting your depth on your expertise. And on the right, we have the V-shaped employee, which is the guy who starts maybe working with a technology or a particular domain and becomes very quickly experts on those domains, and they don't really care for having an overall knowledge of the software architecture or the software engineering. And then little by little, they could be learning some specifics, but always very related to their expertise domain, right? So we could have a debate. Maybe we don't have much time, but I could ask you, what kind of shape do you think is better suited for a software architect? T-shaped employee. I agree with you. Others may not agree with us. Because, well, I'm from Galicia. In Galicia, we always answer the questions with one single answer, which is, it depends. right? It depends. I've been watching some of the recordings of the formerly speakers here, and I remember Enrique explaining very well that the architecture that you need for your company or your particular use case depends on your context. And it's exactly the same for the kind of person or architect that you need for your particular context. It's going to depend. Also, yeah. How do you get those shapes? Well, again, to me, I agree with your colleague. I feel more comfortable having discussions and conversations with architects that have a T-shaped employee, because they can have a discussion, a high-level discussion on any kind of topic. Right? Next slide is I wanted to clarify a little bit some typical discussion, because not many people could really make the argue of what is the real difference between a senior developer or a software engineer versus an architect. I think that this picture is pretty clear, self-explanatory almost. It's gonna depend on the scope and the focus of your decisions, your everyday decisions. On the left, we have the software engineer or the developer. His focus is more on writing the application logic. His focus is more on optimizing the code and the logic of your application. Of course, there is some intersection, this overlap, where the software engineers and the architects need to collaborate in different tasks and different discussions to come up with decisions, right? But overall, the software architects, they take different level of decisions that are more significant, as Rubén explained, decisions that has a higher level impact on your software. I mean, we could discuss about some examples. I don't know. A software developer could be maybe selecting the linter or the style guide for the code. That's a decision that maybe doesn't have an impact, a real big impact on the evolution and the maintainability and the extensibility of the system. But the software architect might be taking the decision of running this code for example, in a Lambda function, which is taking care automatically of the scalability of your component. So that's a much more significant decision, right? So I wanted to make clear this distinction between the senior developers and the software architects. But I mean, looking at this picture, it's pretty clear that the software architects and engineers have this overlap, this intersection, because software architects need to be hands-on. They need to be able to have these technical discussions with the software engineers every day and come to agreements with them. There are very well patterns or anti-patterns in the architecture world. Maybe you've heard about the architect in the ivory tower, right? That's a metaphor for saying that some architects are living in a not very accessible place, so they are not getting the right inputs for taking their decisions, and therefore the decisions are not the right decisions for their context or for their company, for their organizations. Another metaphor is the architect elevator that Gregor Hope explained in his book. That's the same. If you are not able, as an architect, to take the elevator and going down and have these discussions with the technical people using their technical language, your decisions as an architect could be that they are not good decisions, or maybe they are not going to be able to become implemented because you didn't have the right conversation with the technical team. So yeah, I wanted to share with you these examples, these anti-patterns that we should avoid when trying to be or do our best as software architects, right? Always be hands-on, always have technical conversations with your technical team. Also, I wanted to have a word on the career paths. So if you start your professional career being a software engineer or a software developer, then what is the transition to become an architect, right? Well, first of all, we should say that that's something that could or could not happen. You could be a very good software engineer, and then you might be interested more in the managerial stuff. You become a project manager or a product manager, or even an engineer manager taking care of the people. You could be a developer forever. I have a lot of people in my team that love to spend the 80% of their time coding and their only concern is to write the best code ever or possible, and that's fine. I mean, I love to have these kind of people in my team, and they don't really want to move right and start taking those architectural decisions. They just don't want that, and that's fine. But the natural career path for software engineers is to start working more and more on this intersection with the architects. That's the natural movement, right? You start getting involved in discussions that have more significant impact in the quality of the software. You start participating in those discussions with architects. So it's a movement from left to right, and that's the natural movement. You could also, if you are, you have something very, very clear that you want to become an architect, you could be, of course, doing some trainings and getting certifications, and that is going to give you the knowledge that is going to enable you to participate in those discussions that are happening in the right spectrum of this picture. So once you have the knowledge, because you did your certification, maybe AWS Solution Architect, then that knowledge is going to enable you to participate in those software discussions. And that's how you naturally also became a software architect. Well, I didn't say anything, but if you have any questions, please interrupt me at any time. Okay, this is just a sentence that I got from an article. I think it's pretty important to say that the architect needs to deal with the human side of the organizations. I already explained that if an architect is not able to take the elevator and have technical discussions with the technical team, it's going to be very useless in your organization. And if the architect is not able to have a non-technical discussion with the salespeople, with the management, and understand the company business goals and the strategy, then he's not going to have the right inputs to take the right decisions. So sometimes we underestimate the soft skills of the architect, and a big part of the role of being a software architect is dealing with the human part of the organization. So yeah, don't underestimate this skill. It's very important for a software architect. Now, very, very quickly, let me check the time. Different kind of architectures. Depending on the level where you are taking your decisions and the impact and of your decisions. Enterprise architecture, system architecture, component level architecture, other kinds of architecture like data architect, cloud architect, solution architect. I know that you are familiar with all of them. Maybe solution architect is a little bit blurred for you. The concept is the guy who designs a system given a particular context. Usually, they design a system tailored for a customer with some constraints. The rest of, I think that you are very familiar with them already. Just a few words about enterprise architecture. The main goal for the enterprise architecture is to align the IT infrastructure, the systems, with the business goals of the company. So at that level, you really need to understand what is the strategy for your company and then take the decisions accordingly to that strategy. The tools that they use, I split the tools between the inputs and the outputs. The inputs are the tools that you use prior to take the decision, and the output is how you document those decisions. The inputs, a lot of papers, articles, architecture trends, professional companies doing reports like Gartner, those are very valuable inputs. And then how you document your outputs, your decisions. The standard C4 models, architecture decision records, Wordly maps. And I know that these tools have been explained here before, so I think that it's not really worth it to go into the details, but, well, we could. Examples of this enterprise architecture. When a company or an architect, enterprise architect, takes the decision of signing an agreement with your cloud provider partnership. That's the perfect example for the enterprise level architecture decision. System architecture is all about your system. As we explained, the aim of this architecture is taking the right decisions that affect the quality of your system, and very especially, again, with the view in the future and the evolution of your system. The tools, again, same tools, articles, papers, architecture decision records. The outputs, architecture decision records, diagrams using tools like PlantUML, which is very convenient because you can save your diagrams as code in your repositories. To be honest, I prefer other tools, but that's another debate. Examples, the typical decision. Do I need a distributed microservices architecture? Do I need a monolith? Well, that's the typical decision that a system architect is going to take, architect is going to make. Next slide is about component architecture, and some could argue or debate that this doesn't exist, but this is my opinion, and why I think that there is a level of architecture underneath the system architecture, because I think that significant decisions could be taken at the component level. That's why I think that there is an architecture at the component level. The tools, the usual tools, the architecture decisions, normally usually you create some markdowns or some documents and you put it with your technical documentation. And an example is the micro frontend architecture. Yeah, and again, I think that, for example, I consider the UI one component or a part of a system, or part of a whole. And really, believe me that you could take very significant decisions at the UI level. Like, for example, if you're using module federation or you're using web components. Those are significant decisions that are going to impact the quality of your software in your future. So you might agree or not, but I think that the architecture at the component level exists. And now, the case study. A short journey. Let's explain a little bit as introduction. We work at DXC. DXC is an international IT company, a service provider. But today we are going to focus on one of the divisions of DXC. We have different verticals for different sectors, military and defense. We have healthcare, banking. We work for the insurance software company, software and BPS division. DXC is the #1 insurance IT provider for the last 40 years, maybe more, because it's been 40 years since I joined this division 10 years ago. We have, I've seen 1,300 customers. Somewhere I've seen 1,900 customers in other articles. We have many customers all around the world. And our core business is to create software products that we call PAS, Policy Administrator Systems, right? Our policy administrator systems, just to give you a feeling of the magnitude, today they are administrating millions of policies and almost 20 million policies in the cloud already. And we have presence in more than 70 countries. I don't know the numbers of the employees. I know that only because in our organization we have teams building the software, we have sales, we have teams doing delivery. I didn't did my homework, but I know that only in the build part, creating the software, we have almost 1,400 employees just creating the software, the base products. So it's a huge, huge software company. Okay, a little bit of the timeline. 40 years creating insurance software, delivering policy administrator systems under license, and providing professional services. So we are selling these products, and then customers do whatever they want with the product, but normally DXC is providing some kind of maintenance and support. In 2015, the conversations there were around digital first, exposing all the business functionality through API. That's what we call API enablement, and omni-channel, right? Starting to use the modern UI frameworks to consume the business functionality, those APIs, those new APIs, from different channels, right? Mobile, web. That was the trend there, and that's when I joined this organization. 2018, conversations were around we should move to the cloud. We signed the partnership with AWS, which is our cloud provider. 2020, we should move our portfolio of products to a different model. Let's move away from the traditional delivery. Let's try to deliver software as a service. And also, as we will see later, let's try to build an internal development platform to support this transition, this modernization. And today, we are thinking about maybe we should create or expose some of the functionality that we have created, the tools that we have created for our development teams, our product teams. Maybe we should also allow our customers to build their own solutions using our tools. This slide is about how the insurance companies were approaching the challenges and the decisions in the last decade, basically. On the right, we have a screenshot of a DXC paper that I stole, and it's explaining not the challenges, but the difficult decisions that these insurance companies were facing. They should be taking the difficult decision of investing in modernizing their current system, their policy administrator systems, or maybe they should be going straight to the digitalization, which is a word that I think that it was the trend back in those days, but today is more like moving to the cloud and start consuming software as a service instead of just digitalization, which is, for me, is more like, as I said, it's just exposing the functionality through APIs and having different channels. So our customers, they went through these decisions, and believe me, they are not easy decisions. I remember my old boss, the director of architecture in DXC, he used to tell us that no CEO, the CEO of a company in insurance, they are not willing to risk their bonus moving, for example, moving to the cloud, because that is a long-term commitment, right? It's like a long plan. And these people used to be around like a couple of years. So they just want to make sure that they are getting well paid and getting their bonus, but not taking risky decisions. So that's really the battles that my boss, as director of architecture, and of course the sales team were facing when having conversations with these companies. Modernization of legacy systems, adoption of cloud computing and SaaS, AI-driven implementation, those are the levers, are the drivers for these companies when they need to decide where they are putting their money, where they are investing. Next slide. This is, believe me, coming straight from the brain of my former boss, the director of architecture. And I like to think about this, about him in the middle of the night having this conversation with himself, right? Saying, okay, our customers are telling us that we need to move to the SaaS. Why? Because they cannot afford all the spends that they are doing in keeping their systems secure. That's only hiring the skilled people to keep your system secure nowadays with all the cybersecurity attacks. That's really an expense for the companies. And the companies were saying how we can, I don't know, delegate this, how we can avoid spending this money. Same for the technical debt. The legacy systems were becoming very, very hard to maintain. So people, they didn't find people in the market with the right skills to maintain these systems. And what is even worse, the people that they had, they were retiring. So they were saying, this is like a non-exit road. We need to change our model because we are not able to have a team supporting our current systems. And also buying an outcome, because it's like we don't want to spend a 5 years project until we have the new system. We want to have subscription models, having something as a service, we can configure it and we can start monetizing and making money tomorrow. And also some challenges which also were driving all our discussions when we were designing the architecture of the new DXC products. How we can maintain the unicity or the uniqueness of our customers while delivering SaaS products. Well, you need to start thinking about a configuration strategy, an extensibility strategy, a customization strategy. So these are like the kind of inputs that the director of architecture was getting from the customers, and the director of architecture was, cascading down all these inputs to the architecture team. And also in the right side, you can see the complexity of our organization, where we have a portfolio which was massive with more than 80 products, global distributed teams. Everything was very, very complex. I think that I'm going to stop here because I think that is going to be covered later. And I don't really remember if I need to cover this one, but is yours or is mine?
It's mine.
Oh, it's yours. Okay. Go ahead.
Okay. So we will spend some minutes now going further into the strategic architectural decisions and how are we doing that, right? So basically the PET model is just the strategy to protect, extend, and transform the applications that are existing on the customers. As Aitor was explaining, the customers are willing to take their risk, but in a controlled manner. So there are legacy systems that are expanding to a significant amount of business on insurance. Most of the systems nowadays are still running COBOL in mainframe boxes, and this is something really a trouble to modernize these systems, because it's good to understand and to be aware that the market and the industry trends are moving us to cloud-native solutions, delivered as a service, and so on. But the reality is that there are some technical constraints to that. You cannot apply directly that movement in one shot, and you need a strategy for doing that. So DXC, with this amount of customers, there are different maturity levels, and depending on the products, some of them are, let's say, easier to move to modernize and to adapt to cloud and so on. But there are others that cannot be left behind. So depending on the context, the strategy will be different. But protecting is the first pillar of the strategy, because if something is running and there are exposing core functions to their clients, the insurers, of course, has important customers. So the business needs to keep running. So you need to protect the core functions, and maybe they need to still running in mainframe and in COBOL for a while. That's fine, but it cannot be a dead a dead path. Even protecting this context, we still need to provide some extensions or integration points to make little by little, progressively, more cloud, not native, but cloudify, let's say, these systems. And then once you are able to do that, the mindset of the CTOs or the owners of these systems will be more willing to take the step forward by maybe replacing the system. But they need to get trust on what we are doing while extending little by little these systems. And then the latest stage is to transform with these concepts, moving to the cloud and start leveraging really the services that the cloud providers are offering, right? Not just doing rehosting our system in the cloud is not modernizing the system. It's just moving your workloads to another place. You need to take advantage and leverage what the cloud providers can offer. And so which are the enablers for that? Basically, okay, there is a strong partnership with AWS. Why AWS? Because AWS is the lead cloud provider, taking the 33 of the market share, and is at the age of innovation. So DXC is in partnership with AWS, and there are thousands of employees like Aitor and myself certified on AWS. We are both AWS solution architects certified with AWS, and there are multiple solutions that have been built together between DXC and AWS. So this is one of the drivers, of course. And the next pillar is that there are cloud native that are born on the cloud, let's say, because there are some products, as we were saying, that are still in mainframe and so on, but there are new products. These new products are really thought and designed to run in the cloud. So the architectural decisions for these products are extremely different from the decisions you need to take for protecting running systems since 40 years ago. So there is another pillar, which is that wherever you design, it needs to be based in components, composable architecture. And all these cloud native products are exposing its functionality through APIs and following and event-driven architectures. This is some of the core decisions to make these products sustainable across the time and keep them evolving. So for the protection, as we say, the protection strategy relies on adding new integration points for these products that allows us to extend their capabilities. So these legacy products still have a chance to run in the cloud partially. Okay, so the core of this strategy, as Aitor was introducing before, is to come up with an internal development platform. So the internal development platform is just a suite of well-integrated but independent software products that, with the goal of help developers, it's worthy to remind that there are more than 1,000 developers in the company, in the insurance software company, to help them to build better and faster SaaS insurance software. And important, this software needs to be operational at scale. So we've started building this platform like 5-7 years ago, but the reality is that nowadays there are tens of clients running this platform and running their products, running their business on top of this platform. So is not enough to build the software and to deliver a nice platform, but it needs to be operational at scale, and you need to be able to take care of multiple aspects around operations, security, deployments, patching, all the important operations need to be covered. This is the architecture reference of the platform. There are different areas, and the platform is covering the main pillars according to best practices in the market, in the industry, while defining a SaaS product, right? So there is an UX components based on a design system composed of multiple UI libraries with reusable components, as we will see later on. There is a strong foundation for the identity and access management based on AWS native services like Cognito and Lambda, AWS Lambda functions for custom authorizers. On the infrastructure side, the most common services are like containerization technologies like ECS, or the most common one is the Lambda functions. So there are different flavors, of course, that this platform is supporting, like Windows and Linux, and as well a path for the legacy systems with AWS M2, which is the solution for mainframe modernization and relying on Micro Focus and so on. Then the cyber defense is it's aiming to cover all the areas around cyber security, especially the security monitoring and the application proactive application protection. We will see more details about that in a minute. And of course, the life cycle development. The platform is not for running the workloads of the customer, but for building and supporting the full or the entire life cycle of the software development in a secure manner, and attending to or align with the highest standards while you are building software. I'm talking about quality. So how? What's the foundation of that? I mean, how do we progress and move from the ideas to solutions, let's say? So there are like 3 laws of SaaS that are coming from our director of architecture and platform engineering. And the first law is that you are delivering software. So you've never, when we say you, is the consumers, and the consumers of the platform are other development teams. So the final goal of the platform is to create a common basis, a common set of services covering multiple areas that other product teams will consume to develop their business products. And this is the final goal. These products will be delivered to final clients. So the platform itself is never, is not adding direct value or direct outcome to the customer. So the first law is never touch or never modify your code base of your solution. And the related packages on AMS. AMS is the automation management services, is the framework that we have built, a composition of different tools and processes that support the whole software development life cycle, the process from inception, from the build until the deployment phase. So the second law is to usually the products for managing policies, for managing claims, or for new business, or wherever in insurance, all these base products usually need some kind of extension, configuration to attend to meet some specific client configurations. While doing that, we need to respect the first law, which is never break the base code of the product and add just extensions on top of that, but never touch the base product. And the third law is wherever you do, we need to avoid manual intervention while deploying the software, and using always the automation management services. And there is a corollary for these three these three laws, which is that the backwards compatibility principle. We need to ensure that wherever, as product teams, when we are developing something on top of this platform, we need to ensure that that's backwards compatible, to ensure low risk upgrades, and of course avoiding any kind of disruption on the business side, and avoiding breaking the client code. So based on these three laws, we are introducing the decision-making process, because there is a process that is overseeing all this activity from ideas to execution. How do we do that? But the process starts, the first task is writing white papers. Usually the architects, even different kind of architects, will write white papers that start, the inputs are identifying the industry trends, identifying the pain points from the engineering teams, because as Aitor was saying before, a software architect needs to take into account the reality around them, right? So because at the end of the day, the outcome of a software architect will be the input for the software developers. So both pieces need to be in sync. And another input is the business requirements. So with all that in mind, the white paper it will be like the deliverable will be a document setting up the context, the problem statement, why do we need this change, and which are the proposed solutions. Right? And then an impact assessment is always documented, considering the different main priorities like security and performance, scalability, etc. The next task is to review and approve this white paper, and once it happens, we get a new architectural decision record. It's basically to keep track of the main decisions that the architects have taken around a specific system, for example. So once it's reviewed and approved, the next step is to execute that. It means to translate these ideas into implementations. For doing that, basically all the products, in this case the internal development platform, has its own roadmap, and the product manager, together with the architects, will shape the platform based on different ADRs. So some of the Azure principles, more in detail. The first thing is that it's born like a cloud first and SaaS. So the benefits of moving to the cloud are really well known, like flexibility, scalability. For example, with on-prem architectures, it's really a challenge to escalate, to scale, and to add more compute resources on the fly and so on. So all these factors are taken into account while designing the platform. So the cloud first and SaaS is relying on all these key pillars. So covering or taking into account all these pillars that, on the other hand, this is not new. This is something that is on the like an industry trend when you move to the cloud, right? So the platform will have ideas or solutions for how to manage the multi-tenancy and the isolation strategy. So the main principle behind that is that you are selling or delivering your software as a SaaS, so for multiple clients, and all these clients are living on AWS. So these clients need to be properly isolated, one from each other, the customer data, of course, and all the infrastructure related to each of these clients needs to be isolated from among them. Scalability and elasticity while using the right resources on AWS, the right services like Lambda, ECS, or Dynamo are services that by default are quite scalable. The foundation for the identity management. On the operational side, once this platform is up and running, we need to monitor what's going on, what's happening with the platform. And this is really important, the well-architected framework, and we will see some references there and some links to the well-architected framework, because this is a powerful tool provided by AWS to assess how well-architected is your infrastructure in general. So it takes into account 6 pillars, like the operational excellence, performance efficiently, security, reliability, and sustainability. And so all these pillars are really important while you are designing your architecture. Well, just moving forward. This is the target state of the architectural model, and basically is based on event-driven for the communications between serverless microservices. So these microservices can be composed of multiple Lambda functions, and they are consumed through REST APIs. So this is a very basic idea, but important to keep in mind whenever you design your system, to make it composable, to divide your functions in different microservices. As we are in cloud first, under the cloud first principle, whenever it's possible, we want to go ahead with the serverless stack and basically decoupling the architecture and making it composable solutions. The secure principle, of course, secure is at front of any kind of decision. Wherever you decide, if you cannot ensure that it's secure by default, you will fail. Your strategy will fail, and your customer will be disappointed because there is a security breach. So this is one of the main concerns, actually, of the customers. Well, my data was on my data center in-house, and I felt comfortable with that, but now I don't know where is my data. My data is in the cloud, but what does it mean? How do you ensure that my data is properly protected? So for doing that, there are many different tools and processes to keep the customer data protected. But there is a shared responsibility on doing that. Moving to the cloud, AWS or the cloud provider will set the boundary on or will take care of the security of the cloud, not in the cloud. The difference is that they take care of the physical access to their facilities, physical protection of the data, protecting the hosting layer and the virtualization layer. But on top of that, you as a customer will start dropping and configuring, let's say, EC2 instances, virtual machines on AWS. These virtual machines will contain some kind of software. AWS has nothing to do with that. It's your responsibility as customer to configure the security of the software you are deploying on your EC2 instances. And the same for the encryption of your data. If you are using a storage service like S3 in the cloud, it's up to you to encrypt this information or to keep it in clear text, let's say. So there is a shared responsibility, and this is important to keep in mind. And of course, there are best practices to keep the information protected and to react to potential incidents, security incidents, and it's based on the NIST cybersecurity framework. The NIST is the National Institute of Standards and Technology, and basically there are like 5 core functions, right? And these 5 core functions are identifying. You need to be aware of your assets in the cloud. You need to know which are your storage instances, your EC2 instances, your Lambda functions, or everything that is subject to be attacked. You need to inventory that, make an inventory of that, and protect that. So the second step is to protect that by adding some firewall rules, some CL, some other services that are protecting your assets. And you need to be reactive to have a mechanism to detect security breaks or security incidents, and then have a mechanism to respond to these incidents and to contain potential attacks. And finally, to have promptly or a response team that is able to recover or have some self-healing solutions on your system that, based on some conditions, is able to automatically recover from issues in general. So, using this framework, there is a cyber defense solution which is relying on the cloud primitives on AWS, and in addition, it's using 2 commercial off-the-shelf or 2 third-party products which are focused on this area. So at the end, is with this solution, it tries to cover the 5 core functions of the NIST cyber defense framework. And Prisma is more focused on the application protection. So it provides security around your code, around your running systems. And then the security monitoring is around looking for all the security information and event management, the CM, providing investigation and forensics about different events, and responding to different security incidents. And of course, there is a you need to place a team or a service behind that. Not everything is technology, but the cyber defense strategy is relying on people and processes. So by using this solution, on the left-hand side, people will look at these consoles on Prisma and Splunk and ServiceNow as the incident management tool, and will escalate potential issues to incident handlers and work together with the concerned support teams, infrastructure teams, security teams, other operations teams to fill the gap and to fix the security issue or the vulnerability. Another principle is the DevOps cycle, or the fully automated. Whatever we do needs to be automated. This is one of the principles to make this, to deliver this at scale. If we want to move forward from tens of clients to hundreds of clients, only automation, not only, but automation will be one of the main contributors to achieve that goal. So the AMS is the foundation of the automation framework, and the goal is to build, to cover the full life cycle from build to deployment stages. And there are a set of tools and processes to cover that. So GitHub is the source code repository. All the source code is residing there. And Artifactory is when you build your application, you generate an artifact that will upload to Artifactory. So this is the artifact repository. And then Jenkins is the main orchestrator and is running jobs to enable the build and deployment processes. Terraform is the infrastructure as code solution. So all the infrastructure is writing as code using HashiCorp, which is the language provided by Terraform. And then we have 3 homemade solutions, which are to manage environments for customers and to define or to create releases or manage releases of our software, and then composed these solutions, like grouping these solutions together logically under the same service. So at a glance, the main pipelines here, the main processes are the build process, which is the push pipeline, and the build process needs to get aligned with some stages, right? So it runs automatically the unit testing, vulnerability scanning, code quality with SonarQube, and if everything goes fine, the outcome is a new artifact that is automatically uploaded to Artifactory. So at this stage, it's possible to, as an early stage, deploy this latest change in a developer environment, but the artifact is not ready to be deployed in a customer environment. So the next is the pull pipeline, and the pull pipeline is the one that is moving our artifacts through different environments on the life cycle, on the software development life cycle, and it's running different kind of tests, from integration testing till functional end-to-end testing. And these kind of tests are executed in different kind of environments. And if everything goes fine, there is a new release of our artifact, and that release can be optionally promoted to different customer environments, or depending on our change management process, it can be automatically promoted, or it can be stored like a general available artifact to to be deployed in different customer environments. And this is what the update pipeline can do, is deploy the artifacts for us automatically based on a predefined list of, a predefined configuration, let's say. Well, the full automated system is it's a bit complex. There are a lot of interactions, a lot of relationships between all these tools to make it happen. This is just to give an overview of our design. And finally, I will finalize with the highlighting the importance of the end-to-end testing. When we suffered the pandemic situation, we had the director of the World Security Organization saying that test, test, and test, and it's really key to keep a system performant and sanitized, right? So Mycon said that you need to take into account the test pyramid. So not just writing tests, and not just because writing more and more tests, your system is more secure, more performance, more high quality. The idea behind that is that you should perform more time and spend more effort writing unit testing, and then as you move up in the pyramid, you should spend less effort in more expensive tests, more dependent tests like integration tests and functional tests and UI tests. So the idea is to spend more effort in the cheaper or less expensive tests, which are the unit tests, and then try to get a solid set of tests on that area. With that in hand, this is the Azure testing approach, which is following this principle. And in this case, it's adding more details, covering not just the functional testing, but the non-functional testing. So for the load and stress test, the performance test, security and usability tests. And here we can see some examples of some of the tools that we use on the different stages, and the execution on which pipeline these tests are being triggered. So the push pipeline is running unit test through X unit, J unit, Jest, or other similar tools. And then on the pull pipeline, more specific tests around integration, the API, and so on are executed using Playwright, Cypress, and Newman for API testing. So, well, I think that's all so far, so handing over to Aitor. Thank you.
Okay, I warned you guys, we are rookie speakers and we prepared way too much content. I'm going to speed up, for sure. Last Azure principle is the UX design first. This is my area of expertise. Remember the T-shape. So I'm an architect with my depth shape is the UI and UX. In the right side, you can see a screenshot of one of the papers that I prepared every year, taking the inputs, the inputs from my director of architecture, telling me what is the strategy of the company on the UX side and the UI, and also then it's my job to do the research and investigate, read articles, watch a lot of videos, and then write these papers, which, as Rubén explained, these papers get reviewed, and if approved, they become architectural decision records. So this is the one that I prepare every year. I have others in a lower level lower level topics. For example, I have other papers on low code, no code development, or for example, Angular versus React papers that then also became decision records. So first input from the strategy of the company, my director was telling me, Azure Solutions is about having composable solutions running on the platform. So we needed a UI architecture which was scalable, cost-effective, integrated with our identity and management strategy. So the picture that you can see there is just the serverless application pattern provided by AWS, and we are following from A to B, from point to point. So it's just, I'm gonna just comment that to be able to host our UI applications in an S3 bucket, as you may know, we need UI frameworks that support the single page application pattern. So it's S3. The S3 bucket is just serving static files to the browser, basically a bunch of JavaScript files, and then everything is running in the browser. So that's the only thing that I'm going to comment on this picture, unless you have any question, and we can go into details. Maybe I know that you're already familiar with this serverless pattern. Other inputs, as part of the platform, we need to provide a good developer experience for our product teams. The technology choice, we were deciding between React and Angular. We really loved React, but another criteria to take this decision is what is the skills and the expertise of the people that we have in-house in the company. The 80% of the UI developers in our company knew Angular, so we had no other choice that support both. And we are supporting both. We used to support both, not anymore, just React now. Well, another story, long story. To be composable, micro frontends. That picture is the quadrant for the Tech Radar. I think it's from 2020, where they were recommending the companies to adopt the micro frontend architecture. And as I know that microservices architecture is a subject that you didn't touch yet, I committed to come back and explain our architectural approach on micro frontends, maybe later, another day. And this is also another picture explaining our micro frontend approach, which is based on hyperlinks. Everything gets deployed. I mean, you can see 4 different web pages which are composed to have so the user gets the feeling that he's interacting with a single application, but that application is composed by different micro UIs. Everything is deployed in the same bucket, and we are using different routes to navigate to the different micro UIs. And I would love to explain a lot of the architectural decisions and the reasons why we are able to, or we are actually following this architecture. But I think that, as I said, I'm committed to come back another day once you are more familiar with microservices architecture and explain this micro frontend architecture. Another input, our UI UX need to be modern. On the left, you can see some COBOL screens. On the right, you can see modern web applications. To be consistent, we are talking about composable solutions. So if you have different UIs with different experience, that is not, I mean, if you are providing a disruptive user experience that is not consistent because you don't have the feeling of interacting with a single application. So sorry about this slide, but on top you can see UIs from different products with different technologies, with different maturity levels of UIs. And our proposal to fix that is to create our own open source design system. It is called Hashtag. As I said, it's open source. You can go to this public site, check the documentation, go to GitHub, make contributions. I would love to see some contributions from you guys. A design system is nothing but some style guidelines, well documented, tools for developers, like a library that we call CDK, the Component Development Kit, written in React. As I explained, we gave up on Angular. And the designer tools. We have different tools for designers to cover the different stages of the UI development workflow. So we have the right assets, we have the architecture decision records. Was this enough to enforce our architectural principles? No, it was not enough. We were struggling, so we took one step more and we tried to enforce the whole workflow. We wanted to be design first, and the people were actually forgetting about doing design. So at the end, we were not getting the outcomes that we were expecting. So we were enforcing this workflow where it is called design ops. It's not something that we made up, it's something that we adopted. And we start by analyzing the user experience that we want to have, creating sitemaps, user workflows, meetings with the product owners to know really what are the requirements of the UX. Then we go through the low fidelity designs with wireframes. We have tools for that. High fidelity designs, again, we have tools for that. We have our design kit in Figma. We have our design library in UXPin. Then we have the usability testing, because we are forcing our development teams to go through the prototyping phase. So in the prototyping phase, they are using our coded components. So they are forced to use the components which are compliant with our design system, and getting real user feedback in this usability testing phase. And then we moved the prototype to the code. In this step, we are also ticking another checkbox, because one of the inputs that my director was telling us was, we don't have enough developers, we don't have UI developers, we need to have a strategy which involves, at some level, some low-code approach. Well, our prototyping library, since it's leveraging our React-coded components, once you have your prototype, then you can just copy-paste all the presentational layer and you have your UI already running. So that's some level of low-code approach, while maintaining all this design thinking process, starting from the early stages and doing real design and creating a user-centric product. Do we want to cover the mandate, or I don't know if we have time.
I think we are running out of time.
I think.
So maybe we can jump to the lesson learned.
Yeah, I think so. I think so.
Just 5 minutes more.
As I said, yeah.
We will really do.
Way too much content. We are rookies. Apologize. Let's discuss lessons learned. First one. Architectural decision records and an internal development platform can solve the culture. So even if we took the right steps, we had the right architectural decisions well documented, we were struggling. We were trying to enforce our principles with some development teams. Just a couple of examples. When we were, reviewing the architecture of some product teams, they were telling us, my product is running in the cloud, is running on the platform. I'm compliant with our principles, our architectural principles. Well, okay, running on the cloud or on the platform is not the same as being a SaaS product. I mean, it's very, very different. You don't have, for example, you don't have a strategy for configuring your services or extend your services. How you're going to deliver some customization to your customers if you don't have that strategy in mind. So our development teams, they were all about infrastructure and technology, and they didn't have the culture to really become SaaS product development teams. They didn't have the innovation in mind, they didn't have the configurability in mind, and that was really a struggle. So yeah, that could be mainly because DXC is a service provider company, and we are working on a division which is a software company creating products, but the culture is still, delivering projects. Some people, they were still thinking about selling products with the license, running those products on data centers, and instead of subscribing to a service. Guidance versus governance. Okay, this is something that every company with an architecture team needs to take into account. Guidance means you have your architecture decision records, and this is the best practices, and we are recommending you to follow those principles. While you're still keeping some flexibility, this is our recommendation, but you have your freedom. Governance is, we have mandates, and we are enforcing you to be compliant with those. The good approach is nor the guidance nor the governance, is the balance. You need to be able to provide the rails so your product teams can follow your guidelines, but still keep some flexibility and some freedom. This is just a summary. High quality software is cheaper to produce and keeps your team happy. Okay, this is one of the most important things that I would like you to retain. I mean, we could argue some of the topics that we shared today, but for me, this is not a debate. When you have their architectural right decisions in place, when you have your governance and your guidance, and you are producing good quality software, that it translates, either you want it or not, that is going to be translated in a better environment for your workers. If you don't have a good architecture or the right processes, it's going to be always a crisis period. You will be fixing bugs. You will be always stressed. And believe me, you can believe me or not, but really the happiness and the well-being of your workers really has, I think that is going to be 70% of how good is the quality of the software you are producing, and maybe the 40 or the 30% is going to be if you have the right management, right? Because that is also important. But this is something that I would like you guys to retain, because in the near future you will be making the choice of joining a company, and you are going to be asking yourselves questions. If you can keep this one, I think that these 2 hours will be worth it. Quality of the software of the company that you're going to be joining is going to determine the 70% of your happiness working on that company. Timing is important. Well, this is something that we didn't really explain. So it's working with engineering teams when you need some utility engineers always think that they should be building the solution themselves. In the world that we live today, which is evolving so fast, what is today a custom build, maybe tomorrow is a commodity that you can buy from a provider. So build versus buy is a critical decision that architects take every day. We cannot go into the details today, but if you can research, do the research your own, build versus buy. It's a topic that has been covered in other conferences and speeches in this room in previous years, and this is a very important topic. And the last, good architecture decisions don't always win. Well, as I already explained, sometimes because you don't have the right management and you lack the support from your boss. Sometimes because your product teams don't have the right culture and make the resistance for the change. You can do your job as an architect, software architecture, I mean, as good as you can and take the right decisions, and sometimes you don't win. That's real life. This is a slide that I want you to, because this content is going to be shared with you guys, so these are 4 sources of continuous learning and innovation, which is a key skill for us. It's something that we need to do every day as an architect. So please check these sources. Oh, sorry, I wasn't looking at the right slide. Thank you. Check these sources. For us, for example, the State of JS is a survey that is shared every year, and for me, for example, as a JavaScript developer, provides very valuable assets. Same with AWS, of course. AWS reinvent videos. That's super important. For us as platform engineers and architects, the platform conference, which is happening every year, is also a very good source of information. So please check this slide. And well, this is something that I'm not going to go into the details because it's very related to that picture, if you remember, of those 2 bubbles with the senior developer and the architect. And I was explaining how the software developer could be moving right to start participating in architectural decisions. Today, and thanks to the cloud provider services and the commodities, the trend is that developers start taking architectural decisions early and early. So instead of the developer moving right, is like the development trend is that the architectural decisions are moving left. And that's an advantage for you because at the end, for you, it's an easier transition from the developer to an architect. When I was a developer in my early years, I'm still a developer, but my early years of working, I remember creating a bundle and sending the package in an email, and then I had 0 visibility of what happened next. I didn't know how it was deployed, I didn't know how it was performing, I didn't know anything. Now, if you are building especially applications in the cloud, you will have a lot of visibility as a developer. And that's a major advantage to become an architect faster. And I don't know what's happening. I want to move. And this is my last slide. I wanted to have a discussion about how AI is changing software architecture, but just a very, very short tips. I mean, traditional model, Rubén mentioned, we are AWS architects. We have to study the AWS well-architected framework. We have to study all those patterns because we needed to pass an exam. And then, because we studied those patterns, we could apply those patterns in our designs. Today, everything is changing, and AI is assisting the architectural decisions. Rubén explained the AWS well-architected framework. The well-architected framework, they call it a framework, but there are a bunch of papers that you need to read and study. Today, there is, and this is very, very new, the AWS well-architected AI system. You can inject or ingest your system documentation to AWS, and this commodity, this service is going to assess your system architecture, and is going to provide a lot of insights and a lot of improvements that you can apply to your system. So AI is going to assist the architects in every step from now on, that's for sure. And since we are running out of time, just the final tips, take a second look at the continuous learning slide materials. Follow architecture advocates in social media. There are some local evangelists, very good ones. They've been the speakers here in this room. Pablo Bermejo and Enrique Riesgo, we work with both of them. We are very good friends. Join local groups like AWS Asturias User Group. Very good information. A lot of synergies can happen in those meetups. So those are our final recommendations. Just saying thank you. And if we have questions or time for questions, this is on time. But I would love to answer if there are any questions, of course. You are the IT certified guy.
Yes, it's part of the, it falls in the operational side of things because it covers the incident management, problem management, and change management, which is really important. And in this all DevOps flow, there is, we were not talking about that, because it's a bit boring, the full, the paperwork, because IT is about paperwork and how you feel, how you cover different stages on your process. But IT is implicitly in the DevOps lifecycle mainly, and especially on the operational side, because even although technically it's possible to promote the artifacts automatically to customer environments, we want to deliver our software via internet automatically. Usually we need to fight against your bureaucracy on your company, because clients don't want to get changes automatically on the production applications. They usually need to review the change, the impact, and so on, and this is usually a manual stuff. So IT is there, especially for the change management process. And on a daily basis, the incident management process, we were looking briefly about the security operational center, the response function of the cybersecurity framework is where the incident management takes more place, because you need a team that usually handle incidents, in this case security incidents, but it can be shared with other kind of incidents, performance, scalability, whatever. So the IT processes are implicitly in the DevOps, and especially in the RAM phase.
But can you be a software architect without knowing it or not?
Yes, you can, but it's better.
I know,
Yeah,
I know nothing
in the-
about it.
He's a software
Yeah.
He's a software architect
Yeah,
following
but
the,
I mean, there can be other like develop or something like that. It's like helpful not to know everything.
exactly. It complements your knowledge in the T-shape view. Maybe it's part of the broader knowledge, and of course you can keep focus on the, I don't know, UX for example, or
I just know the basics, so I know what you're talking about, but I don't have a knowledge in depth of my field. So well, I'm part of the architecture team, and I know that I have other experts to take care of that.
For me, the same. I also know currently.
Yeah, the basics, that's a foundation.
We don't present it. So,
Yeah, but it was
okay, so they have another course at the 11. Any other question, quick question?
Well, we have our contacts there, so if you have any other question, and maybe we'll be seeing each other again if we can talk about microservices or microfrontend.
And we
That will be good.
will still be around for the next hour, so if somebody wants to drop any questions.
We will be
And the coffee
we will
machine,
improve
that's
as the speakers. Probably.